Hey guys, it's Mr. Knockman here. Today we're going to be going over the Unit 3 practice free response question on the review. It was broken down into 4 parts, and let's take a look at part A right here. They're giving us a table for the function f of x, evaluated at x equals 1, 2, 3, and 4, and it also gives us the derivative values at those values as well. The table gives us a differentiable function and its derivatives for the selected values. There we go. We're going to let g be the function defined as g of x is equal to f inverse of x for all x's. If g of 1 is equal to 3, what is g prime of 1? Right? What is the derivative of the inverse function evaluated at 1? Right? Now, if you remember when we went over this part, the derivative of the inverse function, right? The derivative of the, this is already the inverse function. The derivative of the inverse function is simply going to be equal to 1 over the original function's derivative evaluated at the inverse function at that point, right? And if you have trouble remembering this, by the way, remember, you can just derive this, right? You just have to remember that if you have an inverse function and you apply the original function to the inverse or vice versa, you should end up back at just x by itself, right? The inverse function and the regular function should cancel each other out, right? And then from here, if you do the chain rule and take the derivative of the outside function and multiply it with the derivative of the inside function, and then that's going to be equal to just 1, you should be able to work it algebraically to get this equation that I have over here. Okay? Now I'm going to go ahead and apply this here. They tell us that we're looking for g prime of 1, which is just going to equal to 1 over f prime of g of 1. And they tell us what g of 1 is. G of 1 is just equal to 3. So this I know is going to be equal to 1 over f prime of 3. Well, f prime of 3 is just the derivative of the function evaluated at 3, which is going to be 2. So g prime of 1 is just going to be equal to 1 over 2. And that's it. Okay? All right. Moving right along. For part B, they're giving us a new function called h, and it looks like it's a composite function built up with, how many functions do you guys think you see here? Right? We got one function, f of, on the outside. I have another function, another f of this stuff, and I have a third function, the third function being 2 times x. Okay, so when I'm taking this derivative, I'm going to have to chain rule this 3 times, right? Because I have 3 functions. I have the inner function, which is equal to 2x. I have the middle function, right? And the middle function is the first f of 2x, right? And the outer function. And the outer function is f of 2x. And you say, Knockman, that looks really confusing, but not really. You just keep the stuff from before inside there when you take the derivative. Okay? So for example, if I go ahead and take the derivative with respect to x for all these right here, the derivative of 2x is just 2. The derivative of f of stuff is still is now f prime of the same stuff, and that same stuff that was in there is just 2x, right? Whatever that was in here goes inside still. It stays inside there. And we do it again for the outside, the outermost function. That's still f prime. But what goes inside there now is your f of 2x. Not f prime, by the way, not the derivative of the inside. The derivative of the outside is just equal to the derivative of the outside with the same stuff inside. Okay? And that's all it is. It's the chain rule being applied 3 times on this problem. So, when I look for h prime of 2, right? Actually, let's do it for x first just so I can show you how we write this out. It's just the multiplication of each of those derivatives. So it's going to be equal to the derivative of the inside, which is 2, times the derivative of the middle function, which is f prime of 2x, times the derivative of the outermost function, which is again f prime, but f prime of f of 2x. That's all it is. That's the derivative of h of x. Now when you evaluate this, right, h prime of 2 is going to be equal to, and we just plug in 2 wherever it's the x here, right? So we have 2 times f prime of 2 times 2, which is 4, times f prime of, again, f of 2 times 2, which is 4 again, right? We just go through and we evaluate this one piece at a time here. So I have here, this is going to be equal to 2 times f prime of 4 is equal to 5, right? That's right there, right? Right there. Can't believe I missed that. Times f prime, I got to evaluate this first. What is f of 4? And f of 4 is just 1, okay? And f prime of 1 is equal to -3. So this right here is equal to -3. So when you multiply this all out, h prime of 2 is equal to 2 times 5, which is 10. 10 times -3, which is going to give me -30. And that's my answer there. Okay? Moving right along. Let's go on to part C. Where are you, C? Oh, there you are. Haha, found you. This one was a little tricky. I did not read this correctly the last when I first did this. My brain went automatically to the mean value theorem, right? When you look at this thing, which is a continuous differentiable function on the interval from 1 to 4, I immediately thought there's got to exist a value such that the derivative at that value is equal to the slope of the secant line, right? That is what the mean value theorem states. But the mean value theorem does not apply to this one because I'm not comparing the instantaneous rate of k to the average rate of k. If I read closely, it's the average rate of f, and I don't know I don't know the continuous values for it. I only have the table for it here. So I just need to find the average rate from 1 to 4 for my f function, okay? So the average rate of change, again, is not for k, but it's for f, okay? So I'm supposed to be looking at f of 4 minus f of 1 all over 4 minus 1, right? You guys remember that? That is the, it's basically the slope, right? That's all the average rate of change is. It's the slope from one endpoint to the other endpoint, right? So f of 4 is equal to 1 minus f of 1, which is -2, all over 4 minus 1. So that gives me 3 over 3, which is just equal to 1. The average rate for my f of x function is 1. Now, the instantaneous rate for k, right, is given to us, is given by this function. So to find the instantaneous rate of change, all we need to do then is find k prime, right? K prime of x. And I just need to find out when does this derivative equal to 1. So we got to do this derivative first of all, right? So this is a chain rule problem, right? I have here the derivative. The 2 is just a coefficient. I'm going to bring that in front. The derivative of the inside is e to the x, because the derivative of e to the x is just e to the x. And then we're going to do the derivative of the inverse tangent, right, of some stuff. And the inverse tangent of that stuff, if it was just an x, it would be 1 over, I believe, 1 plus x squared. But it's not x this time, it's e to the x, which is going to be e to the x squared, like so, right? So this simplifies out. If I multiply this together, that's going to be 2e to the x in the top. And in the bottom, I'm going to have 1 plus e to the, now remember when you distribute, right, you multiply them together. This is not going to become x plus 2, it will be 2x right there. So that's the derivative of that k of x. Now, what I need to do now is figure out when is this going to equal to 1. And this part is some really weird higher level algebra problems. It's not really the calculus part, right? So I have here e to the 2 e to the x over 1 plus e to the x, when e to the 2x. When does this thing equal to 1, right? When you're solving something like this, it might be nice to cross multiply this 1 over 1 plus e to the 2x over to the other side, so I don't have to deal with this fraction. And I would have something along the lines of e to the 2e to the x is equal to 1 plus e to the 2x. When all else fails, right, when you come over this problem like this, try setting it equal to 0. since it's the non-calculator section, I can't just graph the left side and see when is equal to the right side. If it was a calculator section, which your AP exam this year, I believe, is all open calculator, you could just plug that into your calculator and see when is it cross and just get that. If you were to do that, I believe the answer comes out to equal to x equals 0. But I can show that for you algebraically. Set this equal to 0, so subtract the 2e to the x over to the other side and write it from decreasing powers. So I would have here e to the 2x is my highest power minus 2e to the x plus 1, right? And what you need to see here is this is another form of a quadratic function. It's almost it's an exponential, but it's an exponential in a sense that it's almost like a quadratic. This is squared, this is to the power of 1, and this is to the power of 0. So you could try to factor this, and this thing actually does factor when you guess and check this. This factors out to e to the x minus 1 times e to the x minus 1. It's the same thing. Negative 1 times negative 1 is positive 1. Negative 1 times e to the x is negative e to the x times another negative e to the x will give you negative 2e to the x. And e to the x times e to the x is e to the 2x when you multiply that out, right? E to the x times e to the x is actually just going to come out to be equal to e to the 2x, okay? And the middle term works out as well. And that again, that is just mostly a higher level, a higher algebra level type of question. Anyways, solving this, you'll get e to the x minus 1 is equal to 0, so you get e to the x. When does e to the x equal to 1? Well, that means that x has to be equal to 0 for that to be the case, right? E to the 0 is equal to 1. So that's how they get x is equal to 1 for this, x is equal to 0 for this problem. And that's when your k of x has the same instantaneous rate as the average rate of change. But the only problem with that is that on the interval that we're working with on this is from 1 to 4. And my answer is not on that interval from 1 to 4. And since it's not on that interval, we say that there is no x value that satisfies this condition because that's the one that does satisfy it and it's not within the interval that we're looking at. Okay? Okay. Moving right along. The part D is a pretty straightforward question here. Now it's just asking you to find the second derivative of k and then evaluate that at 0, right? So k prime of x that we found earlier was 2e to the x all over 1 plus e to the 2x. Now I know a lot of students tend to say, what happens if I didn't have part C, right? I can't do part D here. That's why it's so important that if you don't know how to do it, you still attempt it and you get something that's there for part C, right? And then when they ask you to do the second derivative, they don't ding you again because you got the second derivative wrong because you used the wrong first derivative, right? They still will give you the credit as long as you understand the process and you did the steps correctly. You still can get a minimum of at least a point on those problems if you just attempt what you have there. So let's say your first derivative was kind of close, but it wasn't right. You might have lost your point for the first derivative, but when you come to the second derivative, you do the second derivative correctly, they'll give you the point, right? So just make sure that you don't just give up on the problem once you're like, oh God, I failed on part C. I'm just not even bothered with part D. You can still get your point here, okay? Now, over here on this problem, this is clearly a quotient. I have a function on top with a function on the bottom. To do the second derivative here, I'm just going to go ahead and use the quotient rule for this one, right? We're going to go ahead and go with this is going to be my low, and this will be my high. So if you remember the quotient rule, it's low d high. So the derivative of the high is just still going to be 2e to the x. That just switched up there, e to the x, minus high, 2e to the x, d low, derivative of 2x is 2. But derivative of e to the 2x is e to the 2x all over low low. Low d high minus high d low over low low. Hopefully after this class you'll still remember this because it's just going to be stuck in your head. And that's the second derivative. You could simplify this, but if you don't have to, then you don't need to, then don't do it, right? It's not asking us, and we're not doing a multiple choice section this year, so I doubt that you'll have to simplify if it's a free response question like this. This should be perfectly good enough, right? Last part is to evaluate this at 0. All we got to do now is just plug in 0 for x. So I'm going to go ahead and do that. This is going to be 1 plus e to the 2 times 0 times 2 times e to the 0 minus 2 times e to the 0 times 2 times e to the 2 times 0 all over 1 plus e to the 2 times 0, right? Now we know that e to the 0 is just equal to 1. That's also equal to 1. That's equal to 1, and that's equal to 1. So this is going to come out to be, looks like 1 plus 1 times 2, right? Minus 2 times 2 all over 1 plus 1 squared. I think in the top here you're going to end up with 2 times 2 minus 2 times 2, which is just going to be 0 over 4, which is just equal to 0. All right. Hopefully this was helpful for you guys. I'll see you guys in the next video, all right? See ya.